In this lesson, we're going to talk about the dot product of two vectors, some properties associated with the dot product, and how to use that to find the angle between two vectors. We're also going to talk about a new vocabulary term called orthogonal. Okay, be sure to set up your notes paper in Cornell format. And let's start with a definition of the dot product. The dot product is another vector operation. We've already learned scalar multiplication and vector addition. So now we're going to talk about the dot product. And the formula is given below. If I have two vectors, basically what I'm going to do is I'm going to take the horizontal components and the vertical components and multiply. And then I'm going to add those two numbers together. So the dot product will not be a vector, it will be a scalar, just a single number. Okay, so we will not have components, we will just have one number when we do the dot product of two vectors. Okay, for example, let's say we've got the vector 4, 5 and 2, negative 3, and we want to find the dot product. So we're going to take the horizontal components, 4 and 2, and multiply. Then we're going to take the vertical components, 5 and negative 3, and multiply those, and then we'll add. So 4 times 2 is 8, 5 times negative 3 is negative 15, and when I add 8 and negative 15, I end up with negative 7. So the dot product is just a single number answer. Pause the video for a second and do example 2. And remember, this one's written in I and J form, but that's the same thing as components. So the horizontal component for vector u would be 2, and j would be negative 1. Okay, for vector v in component form, that's just 1, 1. So take a second and write out the dot product. Okay, so u dot v, horizontal component 2 times positive 1 plus our vertical components are negative 1 and positive 1. When I multiply, I'm going to get 2 plus negative 1, which is 1. Now again, you might want to pause the video and work this example first and then start it up again to see if you were correct. So the first thing we're going to do here, we're going to use our order of operations, start in the parentheses, and do u dot v. Okay, so u and v are negative 1, 3, and 2, negative 4. So the dot product would be negative 1 times 2 plus 3 times negative 4, which would be negative 2 plus negative 12, or negative 14. Now I'm going to take that number, that scalar, from the dot product and multiply it times vector w. So times 1, negative 2. And scalar multiplication, remember we just multiply the scalar times each component. So my answer should be negative 14 and positive 28. Okay, here are some properties of vectors. If you will, pause the video, get these written down. The first property basically says that it doesn't matter what order we put the vectors in, the dot products will be the same. It's just like when we add numbers, it doesn't matter what order they're in or multiplication. Okay, in vector error number 2, the 0 vector is basically the 0, 0 component vector times, if I dot that with vector v, what it's saying is that I'm going to end up with a 0 answer, because 0 times v1 plus 0 times v2, 0 times anything is 0. Property 3 is like distribution. So if I have vector u dotted with two vectors that are added, instead of adding first and then doing the dot product, I can do the dot product of u with v, the dot product of u with w, and then add my answers together. Okay, number 4 says if I dot a vector with itself, then I'm going to end up with the magnitude squared. Okay. And in number 5, if I have a constant times a dot product, I can multiply that constant with one of the vectors and then do the dot product. Notice it's not distribution, it's not distributive because I don't have a plus sign inside these parentheses. So I either multiply C times U or C times V and then do the dot product. You can also do the dot product first and then times the constant outside. Okay, so one example using the dot product properties says the dot product of U with itself is 5. So look at your list of properties and on number 4. Now ours was in V's, but basically U dot U should equal the magnitude of U squared. Okay, so if the dot product of U with itself is 5, then we want to find out what the magnitude is. Well, right now, according to my property, 5 is the magnitude squared. So if I want to know what the magnitude is, I just have to take the square root, and the magnitude of U should equal the square root of 5. Okay, orthogonal vectors. Orthogonal is a term you probably haven't heard before. It's very simple. Orthogonal simply means that the vectors meet to form a right angle. So some synonyms, one of these you should know, the other one might also be new. We call perpendicular lines lines that meet at right angles. So perpendicular vectors are the same as orthogonal vectors. Another word for perpendicular or meeting at right angles is normal. Orthogonal, perpendicular, normal all mean the same thing. The way you can tell if two vectors are perpendicular or orthogonal is by finding the dot product, and if the dot product equals 0, then your vectors are orthogonal. They will meet to form a right angle. And one last formula we need that uses the dot product is how to find the angle between two vectors. When I'm finding the angle between two vectors, we are looking for the angle that measures between 0 and 180 degrees. It can be an acute angle, it can be an obtuse angle, but it will not be greater than 180. So the formula is cosine of theta, theta is our angle, is equal to the dot product of U and V, our two vectors, divided by the magnitude of U times the magnitude of V. If I take that same equation and I isolate the dot product of U and V, an alternate form is written down below. So instead of dividing by the magnitudes, I would say the magnitudes times the cosine of theta. It's the same formula, it's just written in two different forms. Okay, so for example, let's find the angle between vectors U and V. So let's start with our formula. Cosine of theta is equal to U dot V divided by the magnitude of U times the magnitude of V. Okay. U dot V, 4 times 3 plus 3 times 5. Okay. And then on the bottom, the magnitude of U, remember the magnitude is squaring the two components, so 4 squared plus 3 squared, and then we take the square root, which would end up equaling 5. The magnitude of V would be the square root of 3 squared plus 5 squared, which is not a perfect square, so we're going to leave it as 34, square root of 34. On the top, 4 times 3 is 12, plus 15 for 3 times 5 is going to give us 27 over 5 square roots of 34. Now remember, we're looking for the angle, so make sure that your calculator is in degree mode. And to find the angle, we're going to have to do second cosine of 27 divided by 5 square root of 34. Be sure you put parentheses around the denominator. And when you put that in your calculator, you should come out with theta is equal to approximately 22.2 degrees. If there was anything in these notes you are still unsure about, please put a question mark beside it and remember to ask about it when you come to class tomorrow.